The European Organization for Nuclear Research, or CERN, is one of the biggest and most renowned scientific research facilities in the world. Some of the most cutting-edge scientific facilities and technology in the world are housed there. It is situated in Geneva, Switzerland. Our grasp of the universe has been pushed to new heights by scientific wonders and groundbreaking discoveries made at CERN. One of the top fundamental physics research institutes in the world, CERN has had a significant impact on physics research. For many years, scientists have been trying to find a magnetic particle with just one pole, either the north or the south, but not both. Despite numerous attempts, magnetic monopoles have remained a mystery to scientists. Many enigmatic occurrences in the cosmos, like the quantization of electrical charge, could be explained by the existence of these particles. But just as it appeared that we had reached the dead end, a group of experts from CERN stepped in, expand upon a finding that startled the whole scientific community. What did the CERN researchers discover then? How might it possibly alter how we perceive the universe for all time? You will get to know this and plenty more as we dive into details. However, before getting started with the video officially, here's a quick reminder that you can subscribe for free and like the video so that we can boost the algorithm. Comments are most welcomed. CERN. You are aware of the activities that take place at CERN, the greatest particle physics research facility in the world, where scientists continuously strive to advance our knowledge of the cosmos. The most recent information from CERN is about to rock the scientific establishment and could even rewrite the fundamental principles of physics. The 17-mile-long particle collider may have achieved the hitherto unthinkable feat of allowing subatomic neutrino particles to travel faster than the speed of light. Nothing is thought to be able to travel faster than light. Famous as the founder of modern physics, Albert Einstein. What if there is more to the story? Recent experiments at CERN may just be the key to unlocking the mysteries of a more complex reality than Einstein could ever have imagined over a century ago. His groundbreaking special theory of relativity is based on the unwavering law that nothing can travel faster than the speed of light, which is a staggering 299,792,458 meters per second. His theories have made it possible for amazing technical developments. But what if they only represent the very beginning of quantum physics? Wormholes, alternative dimensions, and the potential for time travel are just a few of the outlandish concepts found in the mind-bending science of subatomic particles. It's a world beyond our wildest dreams, and CERN's ambitious research seeks to demonstrate that it's all true. 10 years ago, when CERN scientists were colliding particles at astronomical speeds in search of the Higgs boson, also known as the God particle, which is thought to be the tiniest particle in existence, they were searching for the Higgs boson. At the time, researchers hoped that the discovery of the Higgs boson would reveal the workings of the strong force, an incredibly potent attraction that draws particles with the same polarity together like magnets. If not, they would repel one another, earlier than a few months. The troubling discovery. The CERN's brilliant minds were able to isolate antimatter for a full 1,000 seconds, but their most recent discovery has truly ignited the scientific community. Why? Because it has the potential to alter everything we know. Time itself and technology. You see, the famous statement made by the theory of relativity is that nothing can move faster than light. However, even if that isn't totally accurate, CERN researchers have observed a neutrino beam moving 60 nanoseconds faster than the speed of light with a 10 nanosecond error range. If this information is accurate, it suggests that the time limit may have just been crossed. A once thought of accomplishment, impossible. The researchers are still ill, of course. The majority of people have the impression that this cannot be true, but they are seeking peer review to support their findings. They're correct. However, it could be the greatest revolutionary discovery in the history of science. As spokesman James Gillies put it, that cannot be true. The neutrino expert Chang Ki-Young works at Stony Brook University in New York. According to Young, the U.S. spokesperson for an experiment in Japan who isn't so confident about the latest detection of faster-than-light particles, the timing of the neutrino's travel and the global positioning system used to measure it are both important. The range of its mistakes is up to tens of ns. He is not claiming that the CERN researchers are in error. There are others who share Young's doubts that there may be a systematic error that has not yet been found. The standard model extension on which theoretical physicist Dr. Alan Kostelecki has been working for the past 25 years foresees potential breaches. According to special relativity and particle physics, the findings should be interpreted cautiously. He makes the observation that the capabilities of neutrinos have been constrained by earlier measurements. The possibility of traveling faster than the speed of light has not been completely disproved. Kostelecki emphasizes that whenever an unusual assertion is made, it must be supported by an equally extraordinary body of evidence. He continues to be cautiously upbeat. LHC. Now let's explore another astounding revelation that has taken place at the CERN site. The Large Hadron Collider is a sophisticated device that flings trillions of particles around and now runs an astonishing 6.5 TeV per beam energy. To accomplish such a feat with over 50 distinct varieties, a 27-kilometer tunnel must be traveled at breakneck speed. The particles are directed along their complex routes using magnets. The enormous electromagnets known as main dipoles at the LHC generate a magnetic field, each magnet fulfilling a specific function. Each one is enormous, weighing 35 tons, and is 100,000 times stronger than the Earth, 50 meters in length as well. To permit high currents to flow without superconducting coils, it would be difficult to sustain magnetic fields that strong. These magnets, along with the lattice magnets, are in charge of preserving the beam's stability and incredibly precise alignment. The particle trajectories can then be bent to accommodate tighter twists. What would occur if regular magnets were employed in place of superconducting ones is difficult to envision, because a four-fold longer accelerator would be required to produce the same amount of energy. The Schwinger effect is a hypothesized phenomenon, but in July of last year, a study team at the Large Hadron Collider was looking for monopoles, which are magnetic particles with only one pole. They were utilizing the strongest magnetic field that has ever been observed or created by violently colliding two beams of lead particles at high speeds. This magnetic field, which measured about 1016 Tesla, was 100,000 times more powerful than the magnetic field from a magnetar, a highly magnetized neutron star, and roughly 2 billion times stronger than a conventional refrigerator magnet. While at accelerators, the most sensitive search for magnetic monopoles, the scientists discovered zero monopoles. On the mass of these particles, they were able to set the first firm bounds. Goals must have a mass that is at least 70 times that of a proton, a portal. However, following these tests, the organization issued a pretty odd press release claiming that a fracture had appeared in the Earth's magnetic field and remained open for 14 hours. After this declaration, scientists confirmed the opening of the hole in the Earth's magnetic field, sparking suspicion on social media that CERN was opening a portal for something supernatural to enter. However, they reassured the populace that there is no immediate threat to our world from it. However, the experts have noted that the hole's opening permits the passage of strong solar winds. Despite being an essential part of our planet, the Earth's magnetic field is sometimes disregarded in casual talks. Our compass needles always point north thanks to this magnetic field, which also protects us from the damaging impacts of solar winds that would otherwise seriously injure our ozone layer. But how did this fracture develop? As it happens, an uncommon occurrence known as the co-rotating interaction region CIR from the Sun is to blame for this specific breach. In essence, these are enormous plasma structures formed when fast and slow-moving streams of the solar wind collide in the heliosphere at low and intermediate latitudes. The region around the Sun known as the heliosphere is home to the solar magnetic field and solar winds. There may be coronal mass ejection CMEs in this CIR. On July 7th, a CME trapped in the solar wind ahead of the CIR hit the Earth's magnetic field, generating a long-lasting G1 geomagnetic storm. While fissures in the Earth's magnetic field are common knowledge, CMEs are blasted out from the Sun and can generate tumultuous space weather and magnificent noise. Say that this field serves as a shield to protect us from solar storms. These features typically open and close fast, but recent crackdown acts have demonstrated that they can stay open for several hours at a time. And more lately, NASA has been closely monitoring this South Atlantic anomaly, a strange phenomenon in the Earth's magnetic field that has produced a reduction in magnetic intensity, particularly in a region encompassing South America and Southwest Africa. For years, it has baffled scientists. Though it might not have an impact on earthly life, it poses a serious risk to satellites in Earth's orbit, since they are susceptible to high-energy solar winds, and because of the weaker magnetic field during these times. These satellites may experience technical difficulties that result in malfunctions and other problems. The South Atlantic anomaly, a curious phenomenon in the Earth's magnetic field that has caused a decrease in magnetic intensity, especially in a region covering South America and Southwest Africa, has been under close observation by NASA more recently. It has puzzled scientists for a long time. Nevertheless, it might not have an effect on life on Earth. It poses a major threat to satellites in Earth's orbit, since they are vulnerable to high-energy solar winds and may encounter technical challenges that lead to malfunctions and other issues due to the lower magnetic field during these periods. Furthermore, have you heard of sunspots? They are some of the most remarkable features of the Sun, known for their incredible magnetic fields and the radiation they emit in the form of solar flares. They appear as dark spots on the Sun's surface because they are cooler than the surrounding area. They seem like dark blotches on the surface of the Sun, but do not be deceived. In spite of their lower temperatures, these locations are nonetheless very hot, with some of them reaching temperatures of up to 6,500 degrees Fahrenheit. This is due to the fact that they develop in regions with extraordinarily potent magnetic fields that prevent some of the Sun's heat from reaching the surface. Most recently, a sunspot known as AR 2975 created a severe solar storm that gave rise to the stunning natural light display known as the Northern Lights. However, despite the fact that these phenomena can be breathtaking to witness, the greatest solar storms can be highly destructive. For instance, a powerful G3 storm can interfere with radio and satellite navigation, even bringing down the entire internet. The Carrington event in 1859 generated the biggest solar storm ever seen, harming telegraph networks all around the world, and generating auroras that shone brighter than the full moon. Keeping this all in mind, should CERN be more cautious going forward with their experiments? Let us know. Thoughts in the comment section below. If you enjoyed this video, please hit that thumbs up. It will help us to understand our audience and allows YouTube to suggest similar videos to you. Thanks for watching, and we hope to see you at the next one.